Hello again. So this video is to teach you a little bit about tables of values, patterns, graphs, and how we connect those equations to graphs when we talk about patterning, algebra, linear equations, and relations. So to start, I'd like for you to think about some of the times that you have used graphs this year, or it could even be in your previous mathematical learning. There's probably a lot of situations where you've used graphs. So take a second to think, okay, when have I used them? And maybe also think about other times you've seen graphs. So some reasons we use graphs, charts, or tables of values. Sometimes when we look at weather, we look at population, age, income, times when we take a survey, and my next one is my favorite, because Mr. Milne told us to. That is always an excellent reason to use one of the above. So, what are the following? Well, a table of values is a table, it's shocking, I know, that shows you the relationship between input and output values. So it creates that relationship. It shows you how one affects the other. That's very important as we move forward. A graph is a visual representation of the relationship between input and output values. So again, we're taking what we see in a table of values and showing that relationship in a visual manner that's very easy to identify. So some examples of reasons and relationships we may graph are distance versus time, age versus income, other things along those lines. So two quantities form a relationship when they are related in some way. So think about it. We have two things that are related, making a relationship. The key word there is relate. Okay, so we can't just say, oh, there's a relationship because we say there is. You have to prove that. And that's something you'll see if you read a lot of news articles, is that cause does not always determine effect. Okay, so you have to be sure that there's a relationship between two quantities before you say they are related. A variable is a value that can change a relationship. So a variable is anything that can change. Variable comes from the word to vary, or means to change or be adjusted. Okay, so if you can change that value in your relationship, that means it is a variable. We'll see some examples of that a little later on. The dependent variable is the variable that depends on the other variable in a relationship. So, for example, distance is always dependent on time. Okay, if you spend an hour going 10 kilometers an hour, then your distance is 10 kilometers because you have spent an hour going at that pace. Okay, so it depends on something else. The independent variable is the variable that does not depend on the other variable. It's usually something that you cannot control. We cannot control time, okay? So that would be in my previous example when I talked about distance versus time. Time is the independent variable, okay? You can record time, but you cannot go back in time, all right? Important distinction and something we'll go over numerous times in our learning. So a table of values is used to organize information. The independent variable, again, go back to the previous slide, pause and rewind me if you like. The independent variable is placed in the left-hand column and the dependent variable is placed in the right-hand column. Okay, so there's probably going to be two columns, sometimes three, depending on how you set it up, but in most cases there's only going to be two columns. So take a second and maybe review your learning on what examples of independent and dependent variables are. Again, like I said, independent are things that we cannot control. Okay, so things like time. Okay, dependent, distance. Okay, independent, age. We cannot control people's age. Dependent, income. Okay, the odds of you being, say, 5 years old and making $100,000 with little to no education or experience is rather slim. When you graph a relationship, the independent variable and the dependent variable in the table of values becomes an ordered pair. Now the independent variable is placed on the horizontal axis and the dependent variable is placed on the vertical axis. Now horizontal is left and right. Okay, that comes from the word horizon, which is where our perception of sky and land meet. It's always left and right. It's horizontal. Vertical means to go up. Okay? Now when the graph or the relationship on the graph is a straight line, the relationship is called linear. Linear means line, straight line, linear. Okay, that's how that connection works. So now we're going to look at an example. Okay, now I want you to think after I read the example, I'd like for you to think to see if you can reason out what the independent variable and what the dependent variable is. Okay, So here we go. Example number 1. The cost of a banquet at Cranny Banquet Hall is $300 for the room rental plus $20 for each person served. Create a table of values and draw a graph to see if the relationship is linear. So take a second. What is our independent variable and what is our dependent variable? I'll give you a hint. They're not obviously listed in the information that you have right now. Okay, so take a second and we'll move forward. So again, cost at Cranny Banquet Hall is $300 for the room rental plus an additional $20 for each person served. All right, here we go. So the number of people, if we have 0 people, we have to pay the $300 room cost plus $20, okay, times 0 because nobody's coming. So it's 300 plus 0, which equals 300. If we have 10 people, it means we pay the $300 room fee. That hasn't changed. Plus $20 for the 10 people we have coming. So that's 300 plus 20. That gives us a total of $500. Okay, now take a second. I'm going to just be quiet for a little bit. See if you can figure out the remainder of the table based on the number of people I give you. Please follow the structure that I provided for you because you know that I like to see your work. So fill it out just as I've filled it out. So here's what you should have gotten. You'll see as we move down by tens of people, you'll see that between these two values here at 300 and here at 500, the difference is always 200. So between 300 and 500 is a 200 difference. Between 500 and 700 is a 200 difference. Okay, so the difference is constant. It is always based on 10 people, a difference of 200. Now what you need to realize is that it's a $20 cost per person. So the actual constant difference between people is 20, but we've given points of 10. We've gone up in intervals of 10, so it's going to be 10 times 20 or 200. Okay, so think about that. It's relatively the same, but it's just your interpretation of. So if we wanted to graph this relationship, this is how it would look. Okay, so we've got 0, 300, 10, 500, 20, 700, 30, 900, 40, 1100. Okay, and it's going up at an increasing rate. It's a straight line, therefore the relation is linear. So it's linear, but why? Well, if we look at the values in our table of values and our graph, we can consider this relationship linear. But why? Okay, yes, it shows a straight line. But if I was to ask you to extend your thinking, what are you going to say? Give you a second to think about it. Linear relations grow at a given rate. So in our Cranny Banquet Hall example, the cost of renting the hall grows if more people come, or decreases if less people come at a constant rate. I mentioned that a little earlier. The fee to rent the hall is $300. That doesn't change. So whether you have nobody come or 1,000 people come, the fee to rent the room is $300. The only thing that changes is the rate per person. Well, the rate doesn't change, but how much you pay changes. So the rate per person is $20. This increases at a constant rate. So whether you add 10 people or 1,000, the rate's always $20 per person. So that's what changes. If you have one person come, you're only going to pay an additional $20 over the cost of the room rental fee. But if you have 1,000 people, you're going to be paying quite a lot more over and above that rental fee for the room. So to identify relationships, we have a relationship between points. So as the number of people increases, the cost increases. So the cost is dependent on the number of people that attend. Okay, we also can see this relationship in our table of values. So let's look at some of the terms we've gone over. Think about what our input and our output are. Okay, you should be able to identify that our input is the number of people that we have and the room rental cost, and therefore our output is total cost. The input is our independent variable. Okay, a great way to remember this is that both words start with in. Input, independent. Output is our dependent variable. It depends on the amount of input in the equation. In this case, our input value is our x value and goes on the horizontal or left to right axis, and our output value is our y value and goes on the vertical axis. So I'm going to give you another couple of examples to work through. These I'm not going to give you the answers to in this video. This is just for your learning. You can check the answers with me. I'll be happy to help you, but consider this like a little mini homework. All right, so here we go. CarMax car rental service charges $40 per day. Cars for You car rental service charges a $10 flat fee for the rental plus $25 per day. If you're planning to rent a car for a week, determine the cost for each service. So tell me how much CarMax is going to charge you for a week, and tell me how much Cars for You is going to charge you for a week. What's the answer? Okay, so you're going to have to tell me the CarMax charge is, the Cars for You charge is. As an extension piece, after you've sorted that one out, when are the two companies equal in cost? And after how many days is each service cheaper? Thanks for watching, and if you have any questions, as always, you can reach me by email or anytime during class. Thanks again. Bye-bye.